Okay, if we look at these ones, again, you can use all different methods, but I'll just show you the way I would normally do it. So if I look at A, I'm thinking, I could have something like, if that whole bracket, 2x minus 1, let's have a look over here. So if I made u equal 2x minus 1, then du is equal to 2 dx. So I would really need a 2. In order to have a 2, I need a half out the front. If you think about it, I need a half there, so I can have a 2 there. And then that 2 dx just becomes du. So I get u to the negative 2 du. And that's pretty easy to do. We know that add 1 to the power, divide by that power. So if I add 1 to the power, I get negative 1, divide by negative 1 plus c. Of course, I've got to make sure I change that back into x's. Remember, u is, so this will be negative 1 times a half is negative a half. And u, so to the negative 1, so u's on the bottom, and u is 2x plus, minus, that's a minus 1. So you get that? All right, let's have a look at B. So if I look at B, it looks like the one on the reference sheet, square root of a squared minus x squared on the bottom. So it looks like that. So if I just make it look a bit nicer, you can see straight away from the reference sheet, that's an inverse sign of x on a, and a in our case is 5. That one's nice and easy. All right, if we look at C, again, if I think of u to the, u being x cubed here, then du equals 3x squared dx. Now I've got a 3x squared dx if I put a third out the front. So if I put a third out the front, I can have a 3x squared dx. So it becomes a third, e to the u, because that's x cubed, and the rest would be du. Now that makes it really easy, because I know when we integrate e to the u, we just get e to the u. Plus c, and don't forget to change u back to x's, so it's e to the x cubed. So some people actually do that kind of part in their head, which you can do, no problem. I'm just setting it out so you can hopefully see it clearly. All right, let's look at D. D as well comes, you can recognize it straight from the reference booklet. So you've got the square root of, where's my pen? There we go. Thank you, pen. Square root, sorry, not the square root. We've got a 3 squared plus an x squared on the bottom. I'll put dx there. So if you have a look at your reference sheet, that's the inverse tan one. So just remember, for inverse tan, you need the 1 on a. So in this case, the 1 on 3. Then you've got the inverse tan of the x on a, and it's plus c because we don't have any limits. All right. So E. Now E, it's a fraction, and it does look like we might have the derivative of the bottom at the top. So I'm thinking logs. So if I have a look, I'll do it with you so you can see that we don't really need to. So if I make the bottom into u, really I just want the derivative of this on the top, and then I know that I can use logs. If you have a look, it's got 2x plus 1, and actually we've got 4x plus 2. So if we divide by 2, so we put a 2 out the front. So I put a 2 out the front, oops, why is my pen not working? Then I can have a 2x plus 1 over the x squared plus x plus 1. Now, I don't even have to use u's. I just know that the derivative at the bottom is at the top, therefore it's a log. So I've got a log of x squared plus x plus 1 plus c. Okay, so I just had to put a 2 out the front. With f, you can do a few different things. Let's try. So the bit that's kind of difficult is the x squared plus 1 to the power of 4. So if I make that u, that will be u to the power of 4, which is really easy to do. Integrate then. So let's have a look at that. I get du is 2x dx. Now I've got that 2x dx there. So that bit can become du. So in effect, I'm saying I've got u to the power of 4 du. Now that's really nice and easy because u to the power of 5 on 5. So add 1 to the power, divide by that power, and just put the u back in. So I've got x squared plus 1 for u. I can put the fifth out the front, plus c. So that would be your answer. All right.